this picture here is the girls have drawn a controller using like a 6B sort of pencil, like a relatively soft pencil, just because it's easier, and drawn a controller and then clipped it on there and made their own controller for Minecraft. So they were playing Minecraft there, and then just touching on the paper, it completes the circuit and controls the video game. So everything always comes back to Minecraft with us. And this is just in the library, so I'm kind of like a bit of a technology flash mob sort of guy. So I just brought this into the library at lunchtime and sat down with these students that I knew and said, here, have a go at this, what can you do? And then just sort of have a play with it. So here's the piano stairs. We'll see if this works. This is one of my other students was not there when the girls were setting it up, and then she arrived later and said, oh, I've just got to try and test it out. So she was having an experiment with it. This was our first sort of iteration of it, where we used the metal strips that were already on the stairs and just the natural conductivity of the stairs and their wetty sports socks. So that was just testing it. And this is the second time we did it. We made it a bit more robust because we needed to do it for open day. So we knew that there would be lots of people walking on it. So we liberated some like conductive sort of tape from the maintenance department that they use for repairing the air conditioning stuff. You know, it's like foil tape. So I sort of I've gotten good at spotting interesting conductive things where I spot it and then sort of say, oh, do you mind if I have a bit of that? And a bit of that turns into, can I kind of steal the whole roll? So this was our other one. And of course the girls, the music students tune it up differently and like to change the instruments, so they changed it to bells. Now, so here's another example of then moving into the legitimate sort of side. It is then one of the art teachers said to me, oh, one of my students has this project that they've been thinking about, and I reckon you might be able to help them out. So this is one of the Year 12 art students' proper piece for assessment. I didn't totally get into what the rationale of it was, because I was just sort of trying to scaffold a little bit of the technology side of it for her. But what we basically did is she'd made this canvas that looked like a bathroom and a toothbrush and towel and so on, and put these little dots on it. She wanted them to make them look like Mattel sort of things, you know, where it says try me and that, you know, on a package in the toy store, and it says try me. So she made all these little things. She pushed pins through the parts that she wanted people to touch, and they went through to the back, and then we just hung the makey in the back, so just in a snap-lock bag hanging there behind the canvas so you couldn't see it. And then the bath mat there, that's the grounding part. So what you do is you stand on the bath mat and then you touch the artwork and it speaks to you. So the art student then learnt to use some sound editing stuff. So I gave her a crash course in how to use Audacity to record her voice, and she changed the pitch of it to make it really cheesy. So it would say like, hello, I'm a toothbrush, and things like that when you touched it. And it would go through all this other stuff. And how to program Scratch. So this is an art class, not a tech class. And just to, you know, put a project together. So that was a big hit. So back to the reverse side of the Makey again. So this isn't an ad for Makey. Maybe I should be getting, like, you know, what do they call it, like a spotter's fee or referrals or something from the guys at MIT for this. But on the other side, it's all built on this thing called Arduino, and in particular, like, there's a chip in there called the AT Mega, and it's made to be really accessible way of programming things and creating hardware projects. So the Makey is really friendly on this side and still fairly friendly on this side, but there are some really cool geeky electronics behind it that students could then go on to experiment more with. But what I reckon is that then you should just go on to what I would call proper Arduino stuff. So that's the other really cool little thing I'd love to show you. So Arduino is a open source electronics project that was made originally for artists and other people wanting to do some neat stuff, but really lower the barriers to entry and make it easy for them to program and so on. So it uses a C-like language, like it's pretty much C. So my other IT industry friends that program in like proper C and stuff, they help me when I get stuck and it makes sense to them. You know, they've been teaching me lots of bits and pieces. So this is what an Arduino looks like. So it's basically what you'd call it a microcontroller, but it allows you to plug all the electronics and stuff in. And so here is one here. Here's one I prepared earlier. So this is one of my ones, and one of my ones, I say, one of my ones. It's become a habit because they're not very expensive, so they're easy. So once you've got one, then you may as well have more of them. So this is one that I've been tinkering with, and what's particularly cool about this, if you go back to the idea of those old Dick Smith kits, is that it's easiest to use these solderless breadboards, and you just push the cables in. And so what I end up doing is I sit on my couch at home and just sort of tinker with it while I'm watching TV and just trying different things and push it in, and I'm not having to actually solder it all together and then discover that I made it badly and it didn't work. And what it can do is much more powerful. So this one looks fairly complicated, but I mean, you obviously would just start with lighting up one LED and so on. Now, what this one does is works in a similar way to the makey-makey, because I decided I want to figure out if I could make a makey-makey. And so this is a circuit for capacitive touch, so a bit like the touch screen on your iPhone and things like that work. So what happens is when you just touch one of these cables, it would play a sound. So that's what I was trying to figure out. So that's an example of how, like, going from this, like the simple one, has led me into getting back into real electronics. And I've learned more in the last year, or less than a year now, really, playing with Arduino. I've learned more about it than years of unsuccessfully putting together little kits and things like that, you know. So the Arduino, back to the Arduino, it comes in different sort of flavors, of course. So because it's an open project, this is the real Arduino, like the Arduino brand Arduino. But then other companies can make them and improve on them. So the one I've got there is this one. It's made by a company from Melbourne called Freetronics. So you can get this stuff at JCar, which is really cool. And so this is sort of the idea of it. It has this chip, the same sort of chip that the makey-makey has, the ATmega. And it has all different pins and stuff you can plug in and so on. But it comes in different shapes and sizes as well. So there's the Leo stick, so the Leonardo, so it's the same thing but just smaller. So I'm trying to figure out how to make a makey-makey out of one of those, so it would only cost you $30. Oh, and they're even smaller. So I discovered this one the other day, which is a whole Arduino, but it's just tiny, like this big. And it has all different parts that can be stacked on it, so it can be added to the network and so on. These are my photos that I was taking as I was teaching myself how to do it. So starting from just one light, going through to more complicated things with switches and buttons and stuff. So I really commend that to you to have a go at Arduino stuff. You know, the big thing that I've been raving about lately is like kids doing real electronics and really getting inspiration to do things that will really change the world. So this is one of my students, and she looks very little in this photo, and she is little. She's only in year 7 and she's little, and she's this is the first time I decided that she can do Arduino. There's a whole other story behind it, but this is the first time she had a go at doing Arduino, and it just created a avalanche, you know. So what happened is now she has ended up at the point where she's made this. This is her project. So this is a golf glove with flex sensors on it. And then what you do is you put the glove on and you strap the mouse to your wrist, and it has all these things that she's soldered together and created, and you control a video game that she created. So she created a video game and created the interface for it, and it's using the same sort of technology that Nintendo used, like for the Power Glove back in the 90s. You know, now she's just made it herself, and it's really just changed her destiny, really. Like, she's dead set on working in the ICT industry now, and the people that she's met through tinkering with this stuff and entering it into competitions and so on is just incredible. Like, people at IBM and SAP and all kinds of organisations, the research organisations. It just opens doors for kids. So there's her with Stephen Conroy and her showing these bananas to like the head guy from IBM and so on. So it's just, I love it. This is her website as well. So she's become passionate about this stuff. This is her toolbox, which she just loves, having a toolbox with all her tools and bits and pieces in it. And now this is not a uber geeky kid. This is a kid who's like a champion basketball player and involved in all kinds of other things. She's good academically. She's a really nice kid, really, really nice kid, not just, it's not all just about this, but this is really something that she is passionate about. So, and here's another example of like that balance in her life. So this is like from her YouTube channel. Some videos she's created where she's explaining to people how to use flex sensors and Arduino because she wants to share that with other people. And then the other videos are about her guinea pigs. So it's like she's a typical 12-year-old girl, making these videos about her guinea pigs, and then at the same time creating videos on how to do really high-tech stuff. So that's her project, and this is her showing her project off at a thing called Young ICT Explorers, which is a really fantastic sort of open-ended competition for kids to put their projects in and show them off to people in the industry. And so she's done really well in that, and it's just really created this fire inside her to want to pursue ICT. Now, so just to show you back the other side of it, so this is my tech group. This is a couple of years of photos of this is as legitimate as it gets from my tech girls. We have a photo in the school magazine thing, and this year we got to have a robotics photo as well. So how you have the kids there with their hockey sticks or tennis rackets or something in their photo for their team? This year I said to the administration people, I want to have a robotics team photo this year. And they sort of, there's a robotics team? I'm like, yeah, so we have a robotics team. So we've got this photo of the 20 of them sitting there with these robots in their hands. So that's one that will be there next time. So they do a whole lot of other cool stuff like AV stuff for assemblies and so on as well. And we've been tinkering with satellite stuff because I'm a radio nerd as well. So I get them out on the roof of our science building decoding weather pictures. So you can see this is them decoding weather pictures. So this is my other big success at the moment, Minecraft. We've been playing Minecraft in the shadows, so the kids were playing Minecraft. Then we've now got the year 3s had built this whole model of their school in their junior school in Minecraft, and they also built it in Lego as well. So because some of them didn't really like Minecraft, so they built it out of Lego. Now this class, I'd like to claim success for this, but this is like the highest average score in NAPLAN this class, but NAPLAN was in May and we did our Minecraft later in the year, so I can't claim that Minecraft will help you in NAPLAN, unfortunately. But what it has done is this teacher is really becoming recognised as somebody that's using innovative teaching stuff, and it's just because we get a chance to play and then move it into the mainstream. And so I guess the message that I've got for you is, play, and if you're helping other people, you're an administrator or, in a management sort of position, make sure that you encourage that creative sort of play in your staff and let them show you their projects, and then that's where some of the really cool stuff is going to come from. So that's my story. So thanks for coming on the roller coaster.